So as it says, multi-robot systems, flying drones with the ACT Lab. So when I talk about ACT Lab, it's the automatic coordination of teams. This means sort of just how do robots work together and how can we make them so they can work together by themselves? So we're not like controlling them to work together. We're letting the robots do the work for themselves. And the way this worked, the reason I'm putting this in is because you can see robotics still has a lot to go. Like they're still failing at some very simple tasks, like walking over an uneven surface, just walking at all, opening a door, turning a knob, that sort of thing. They're still failing. And if a robot fails, and this robot is what you've spent years working on, and it's like the critical part of the entire sort of thing you're doing, then the whole thing is a failure. So one thing you might want to do is have multiple robots, so you sort of have this like backup, right? So if this robot fails, you have another robot that might be able to take its place or still achieve the goal that you're working towards. This is in our warehouse, so that's where I'm currently at and where we'll be flying the drones today. You can see them take off, and then they plan their pass through so they don't collide with each other and they don't collide with the obstacles in the space. And then they reach their destination on the other side here. But they're able to do so. If you're testing out this algorithm and it might not work, it most definitely will not work, because we usually have a lot of problems we have to work through. You can at least do this in simulation where it's not going to hurt anyone, not going to break any robots or do anything like that. And then you take this and you transition it over to the real robots. And so they can use what's called LiDAR, which is really just lasers going out, and they can find points on the environment that then they sort of relate to like a LiDAR map of the environment with these different points. You can also have like a stereo camera view. So that's just a camera view that then finds these points, and then work together to sort of like collectively find key points that you can use to localize where that robot is. And then like I said, we look at human inspired stuff. So we had a group of people play this game where this is their single person view looking down at the ground. They can see somebody standing off beside them. It's like the person's foot, and that's all they can see. And then in the overhead view in this little black square, you can see the 4 different agents moving in the environment. And the agents are given a task to like build a shape. So here you can see much more agents working together. We can take that and look at it and go, okay, we see these like types of roles these people are taking on. And so maybe we can use those roles to inform robotics. So you can see them take off here, and they kind of go up into the air. They're moving along the grid, along the path that has been solved. They're trying not to collide, but because it's been solved, it's probably not going to collide. One of them actually flies up here, so you can see it go up into the air, which is kind of exciting to avoid the other drone. There's a bit of a delay, and then they make their way to the bottom and to the correct positions. See them fly. What does the problem-solving process look like in your team? These are all great questions. Problem-solving process can look very different depending on what lab you're in, who you're working with, and stuff like that. Right now, we sort of work mostly individually. So like, if I think of a problem, maybe because I'm reading a paper or I'm watching a video or I'm attending a talk or something like that, I'll have like an idea and I'll be like, ooh, maybe I could like change this and make this work slightly differently. Or maybe it's an idea like, oh, I see this opportunity in this one industry, like you could change that maybe. And so there's like a lot of different ways the ideas can come to you. And then you might be like start trying it out, just maybe like through like thinking about it and then trying it out like in simulation or on the real robots. And then you have to collect data and results, and you go through the whole scientific method and write a paper. And then you will submit that paper or present your work somewhere. And that's sort of like the general like way it flows. There's also like a lot of collaboration. So when we are sitting in the lab together or on Zoom together, we'll like discuss ideas and like, what if we did this? What if we did that? What if we sort of do this? And then we'll work together. So like there's some like, oh, you work on this part, I'll work on that part, or maybe it's more even collaborative. And then the cool thing with robotics is it kind of is very interdisciplinary. So if you do want to work on the hardware or the software, or maybe you even want to work in like marine biology, but you might end up actually dabbling in with some robotics because you might need them to go and explore the underwater and different things like that. Or, there's just so many areas that technology is now prevalent. And you guys know this being younger, like you've grown up with tech. Like it's just everywhere. And if you're interested in like nature and like preservation and climate change or anything like that, really, like there's technology there and there's even robotics there to work on.